Hi, we are LockIn A team. Today we are presenting on multi-versioning concurrency control. We hope that after our presentation, you will get a better understanding.
Hi, I'm Nabilah, and today I'm going to share with you a bit about MVCC. MVCC is also known as multi-versioning concurrency control. It is a method commonly used by database management systems to provide concurrent access to database. This is done by keeping multiple copies of each data item. Users who are connected to the database sees a snapshot of the database at a particular instant in time. Any changes made by a writer will not be seen by other users of the database until the changes have been completed. This process will not overwrite the original data item with new data. However, it creates a newer version of the data item and multiple versions are stored. This can be achieved by its isolation property. Isolation provides guarantees in the accesses to data. It ensures all readers wait until the writer is done. The most common isolation level in MVCC is the snapshot isolation. Snapshot isolation reads the last committed values that existed at the time it started. The transaction itself will successfully commit only if no updates it has made conflict with any concurrent updates made since the snapshot. Let's now explore how it differs from locking.
Hi, I am Wenta. I will be explaining how MVCC improve performance compared to just locking. To compare these two, I will be explaining locking first, then MVCC, so you could see the difference easily. If a writer use a write lock, only this writer have access to the data. You will block the reader from reading, and this will cause time wasted for the reader. If a reader use a read lock, many readers can access to the data. However, it will block the writer from accessing the data. Hence, the writer have to wait until all readers unlock the read lock, and this is time wasted on the writer's side. Now, a database with MVCC will store different copies of the same data. At any point of time, any users can access the data without being blocked by another user. That means all users can run concurrently. Hence, the performance is better. In short, reader don't block writer. Writer don't block reader. To illustrate how much improvement in performance, let us use a simple scenario. The assumption is read or write task will take 2 seconds to complete. We gave each database read and write task. You could see that the database with locking, it will take 4 seconds to finish, while with MVCC, it only takes 2 seconds. And that is 100% difference in improvement. Now, I'll pass my time to Qing to share with you what locking remains.
Hello, my name is Qing, and now I'll be talking about what locking remains. In MVCC, there are 4 isolation levels: read uncommitted, read committed, repeatable reads, and serializable. In the SQL server, under all isolation levels, exclusive locks are required for write operations. Exclusive locks are released when transaction ends, regardless of the isolation level. The difference between the isolation levels refers to the way in which shared locks are acquired. So under read uncommitted isolation level, no shared locks are required. Under this isolation level, the concurrency dirty reads can occur. For example, when a transaction is allowed to read data from a row that has been modified by another running transaction and not yet committed, it could be rolled back. Under read committed isolation level, shared locks are required for the concerned records. The shared locks are released when the current instruction ends. This isolation level prevents dirty reads, but since the record can be updated by other concurrent transactions, non-repeatable reads and phantom reads may occur. An example of non-repeatable reads is when transaction A receives the row, transaction B subsequently updates the row, and transaction A later retrieves the same row again. Transaction A retrieves the same row twice but sees a different data.
Hi, I'm Desmond. So under repeatable reads isolation level, shared locks are acquired for the transaction duration. Dirty reads and non-repeatable reads are prevented, but phantom reads can still occur. So what are phantom reads? Phantom reads refers to during the course of a transaction, two identical queries are executed, and the collection of rows returned by the second query is different from the first. Under serializable isolation level, range shared locks are acquired for the transaction duration. None of the above mentioned concurrency issues occur, but performance is drastically reduced, and there is the risk of deadlock's occurrence. So, are there any race conditions left? The presence of race condition depends on the degree of isolation used. We can summarize the concurrency issues for each isolation levels as seen in the table. The isolation level with the most number of concurrency issues is read uncommitted, whereas the isolation level for the least number of concurrency issues is serializable.
Hi, I'm Kaixin, and now we'll talk about the pros and cons of MVCC. The advantage of using MVCC is that it allows interaction with the data at the point in time which you execute your query while maintaining a consistent state. All of the transactions that have completed prior to your query execution are visible to your query. Those transactions that are in process will not be visible to your query, so there is no need to worry about what state to query if there are multiple transactions executing within the database at the same time. This allows your database to handle concurrent requests while maintaining a consistent state between each request. As for the disadvantage of MVCC, the rows that are deleted may still be shown because queries that are previously running saw them as visible rows prior to deletion. This is because the database is maintaining a particular state of the data within the database for each query being executed. There will be a problem of having dead rows which have been marked as deleted but actually haven't been removed from memory or disk. And this will lead to query results being inaccurate. Therefore, there is a need to periodically run vacuum to clear out those dead rows.
Hi, I'm Teck, and today I'm going to share about the application of using MVCC by PostgreSQL and Oracle. There are two different approaches. The first approach is to store multiple versions of records in the database and garbage collect records that are no longer required, which is adopted by PostgreSQL. The second approach is to keep only the latest version of the data in the database, but reconstruct older version of data dynamically as required by using undo, which is adopted by Oracle. In PostgreSQL, when a row is updated, a new version called a tuple of the row is created and inserted into the table. The previous version is provided as a pointer to the new version. As for Oracle, it automatically provides read consistency to a query so that all the data that a query sees comes from a single point in time. Oracle can also provide read consistency to all the queries in the transactions and uses the information maintained in the rollback segment to provide these consistent views. This table compares the two different application approach using MVCC. In conclusion, one key difference is that Oracle needs to write the records in the undo segment for the insert statement, whereas on PostgreSQL, the new records version is created only when a row is modified or deleted. Thank you.
Thank you for listening to our presentation. We hope that you have learned something today.